Okay, so we're recording this. If we want to graph an equation, the best way to do it is to get the equation in what we call the y equals mx plus b form. Which means to get the y all by itself. So in order to do that, of course, we're going to bring the negative 3x to the other side. So we're going to add 3x to both sides so that we end up with 2y equaling, this cancels out, 3x plus 6. Remember, these are not like terms, they can't be combined. So I always like to put the x term first and the numbers separate second, and then I divide everything by the coefficient of the y, which in this case is 2. So in simplest form, that becomes y equals 3/2 x plus 3. From here, we have two ways of going about it. One way is to plot points. And if you have a calculator handy, that will make it quite much easier to plot the points because you'll be able to use the calculator to figure out points. I'm going to do that method first. It's not my favorite method, but it certainly is a perfectly valid method. So you make yourself a little chart and you pick any number you want for the x value. And I always like to pick 0 first because 0 is always an easy number to use. Stick it into the equation, and then you're going to get the value for the y. So if I replace the x by 0, this will be 2 times 0. Well, anything times 0 gives me 0, and 0 plus 3 gives me 3. So my first point that I'm going to get on this graph, here's my graph paper, is the point, the x0 and the y3. And I'm plotting that. Here we are. The x is 0 means I don't go left or right. The y is 3 means I go up 3. It's right here on the y-axis. As a matter of fact, that's what's called the y-intercept. Okay, we need at least 2 points because we can't connect them otherwise. So let's see if we can find another point. Let's pick, I'm going to pick a number for x that's even, and I'll tell you why I'm picking a number for x that's even. It's because then I can cancel out the 2 into that number. Let's say I pick -4. I just want to show you that I can pick really any number. So if I do that, I'm going to get 3/2 times -4, which is obviously -4/1, plus 3. And here the 2 cancels into the -4 and gives me -2. So I have 3 times -2, which is -6, plus 3, which gives me -3. Again, you could have done this all on your calculator, just doing 3 divided by 2 times -4 plus 3, and you would come out with a -3. Which means that your next point on this line is the point -4, -3. Which means here's where we go. 1, 2, 3, 4 to the left, and 3 down. 1, 2, 3. And here, this gives me a second point. And now I can connect these 2 points. Let's see what I can do such a good job on that. Did it get better? Something like this. And this is what your line looks like approximately. Of course, if I had graph paper, I would have a better picture. If you're doing something like this on Delta Math, what you just have to do is click on one point and then click on a second point on the line. Let's say you clicked on that point first and you clicked on this one, and the graph, it'll draw the graph that way. The alternate method of doing this that I had showed you is something called using the slope-intercept method. So I'm going to erase this and show you how this would look if we use what we call the slope-intercept method. And maybe I'm going to leave that on just to show you that we're going to actually get the same line. If I want to do what's called the y equals mx plus b method, again, the first thing would be to get the y alone. So this is the same step. But instead of making a chart of values, you write down 2 numbers. I am teaching. The 2 numbers that we write down are the m, which is called the slope, and that's the number that's in front of the x, the coefficient of the x. And we usually like the slope to be written as a fraction. So if it turns out to be a whole number, we just put it over 1. In this case, it is a fraction. Remember that the slope means rise over run. The second number that we see is what we call the b, which is the y-intercept. That's why this is called the slope-intercept form, which is a number that stands alone, not next to the x, which obviously in this case is 3. With these 2 numbers, we can graph the line. How do I do that? I start by going to the 3 on the y-axis. In other words, exactly before we had this point also, the y-intercept is the starting point of my graphing of this line. So that's right here. Once I have the y-intercept graphed, I then use the slope to find other points. The slope is 3 over 2, which means it's rise 3, 1, 2, 3, go over 2, 1, 2. Notice here's a second point on the line. I could from there also again do the same thing. I could again rise 3, run 2. Run means go to the right. Or vice versa. I could do just the opposite. 3 over 2 could also have been written as -3 over -2, because a negative over a negative is positive, which means from here, instead of going up 3 and 2 to the right, I could have gone down 3, 1, 2, 3, 2 to the left. And again, I could do this another time. 1, 2, 3, 1, 2. And if you notice, all these points are again giving me the exact same line that I had before. Actually, this is my preferred way of doing it, because once you have this, it in the y equals mx plus b form, you can go right to the graphing. Don't forget that it's rise over run. And if there's a negative in front of the fraction, then you put the negative on the top, and it means that you're rising. A negative rise would be going down, a positive rise is going up. A positive run is going to the right, a negative run is going to the left. So that's why when we do -3 over -2, we can go, which is the same value as 3 over 2, we can go down 3 and 2 to the left. And basically, when I'm going to graph lines, this is the method I will probably most commonly use. But if you use the other method, you are going to get it completely right, and it's going to give you the exact same line. Does anybody have any questions before I talk about anything else? Okay, if there's no questions about this, then I want to mention something else that we can find about the line. If you notice, we talk very much about what's something called the y-intercept. The y-intercept being the place where the line crosses the y-axis. And we said the way we can find the y-intercept is if we put it in the y equals mx plus b, the number that stands alone will give us the y-intercept. Mind you, I'm going to tell you that the y-intercept is 3, but actually the y-intercept is a point. So the true way of saying that is saying it's a point 0, 3. When the point on the y-intercept is x0, y3. Again, everybody knows that when the point is on the y-axis, the x has to be 0. So therefore, we just say the y-intercept is 3. It's just easier to say, but we have to remember that the x value there is 0. Now, what we don't get directly from the equation is something called the x-intercept. The line not only crosses, unless it's a line that goes straight across, or a line that's going straight up and down, it will, any slanted line, any line that we can put in the y equals mx plus b form will have both a y-intercept and an x-intercept. But the way we do this doesn't give us the x-intercept. So I'm going to go back, I'm going to erase what we have here, and I'm going to go back to my original equation and answer the question, what if I'm asked to find the intercepts of the line? What if we're asked to find where does a line cross the x and y intercept, x and y axis? And actually the method that we're going to use will apply not only to lines, but later on in the term when we're going to be talking about graphing of different types of figures like circles and things called ellipses, etc., we'll be talking about the intercepts as well. And there is a basic rule. If you're given an equation that you want to graph, and you're asked to find the intercepts, if you want to find the x-intercept, take your equation and set the y equal to 0. Because we know along the x-axis, the y is going to have to be 0. If I take my original equation and I replace the y with 0, I'm going to get 2 times 0 minus 3x equals 6, which now 2 times 0 is just 0. And 0 and negative 3x is just negative 3x. We get the negative 3x equal to 6. And when I divide it by the negative 3, it gives me the x equals negative 2. In other words, the x-intercept is negative 2. More accurately, it means the x-intercept is the point negative 2, 0. If you notice over here, that's exactly what we have. If we go negative 2 to the right, we see that the line is crossing right at this point, negative 2, 0. Again, we very often just say the x-intercept is negative 2, but really the correct way is to say the point is negative 2, 0. We can also use this method to find the y-intercept. But if we want to find the y-intercept, remember what we did to find the x-intercept? We set y equal to 0. So if we want to find the y-intercept, and we don't want to go into the y equals mx plus b, we just have this equation and we want to find out what the y-intercept is, we can do it by setting the x value equal to 0 in the equation. Notice what's going to happen then is I'm going to get 2y minus 3 times 0 equals 6. Again, 3 times 0 is 0, and 2y minus 0 is just 2y. So this gives me 2y equals 6. And we get the y equal to 3. Just as we had said before, we even actually graphed it. The y is equal to 3. Notice if you just plot these 2 points, if you have your x-intercept and your y-intercept, you actually could just also use it to graph the line. Again, as we said before, that's really the correct way of writing this is 0, 3, because when we're on the y-axis, the x is 0. When we're on the x-axis, the y is 0. So we will come back to this several times during the term when we talk about finding intercepts of a graph. And I'll remind you, the basic rule for finding the x-intercept is to put the y equal to 0 in the equation and figure out what the x is. To find the y-intercept, we put x into the, we replace the x with 0 in the equation and solve that. Okay, that being the case, I want to go on to talk about the whole concept of the slope of a line. The slope of a line is the slant of the line, and we're going to talk about how what the slope of the line gives us. We've mentioned that it's rise over run. It gives us a lot of information about the line. It tells us how the line is slanted. And we're going to find out how to find the slope of the line. So I'm going to erase some of this and go on to that topic. Okay, so we've already mentioned how to, once we have an equation of a line, how to go about finding the slope of the line. We do that by putting the equation in the y equals mx plus b form. Okay, so I'm going to give you an equation. And I'm going to ask you to tell me what you, to figure out the slope, and then to tell me what that slope is telling you. Okay, so let's say we have negative 9x minus 6y equals 12. Remember, this is, we know this is a graph of a line because there's no x squared or y squared. It's what we call a linear equation. I want you to find the slope of the line. What is the slope of the line? And once we find the slope of the line, you can give me that answer on the chat. We'll then discuss. I want you to think, what does it mean? What is the slope telling us about the line? While you're doing that, I'm going to be taking attendance. Jesus.
Here.
Good morning.
Good morning.
Jackson. Good morning. Tiffany.
I'm here.
Good morning.
Good morning.
Kayla.
Here, good morning.
Good morning. Tishana. Good morning. Dion. Good morning. Wensley. Good morning. I'm glad to see you have your electricity back. Tatiana. Good morning. Awa Diallo. Good morning. Ashay.
Here.
Good morning.
Good morning.
Eliana.
Here, good morning.
Good morning. Christopher Fleming. Michelle. Emily Michelle.
Here.
Good morning.
Morning.
Anastasia. Anastasia Guerra. Zenabu. Ismail.
Here.
Good morning.
Good morning.
Jaden.
Here.
Good morning.
Good morning.
Ashiana.
Yeah.
Good morning.
Good morning.
Anijah. Anijah John. Thomas.
Yeah.
Thomas, are you here?
Yes, I'm here.
Good morning.
Good morning.
Paul.
I'm here.
Good. Good morning.
Good morning.
Ashley. Angelica. Oh, Ashley, good. Good morning, I didn't see you. Okay.
Here.
Angelica,
Here.
good morning. Tayon. Good morning. Akeem. Akeem Philip. Craig. Craig Ricketts. Giovanni Rowe. Devin Lee. Kathy Waddell. Kathy. Jasmine Elizabeth Wood. Jasmine. Okay. Okay, did anybody figure out what the slope of this line was? Okay, does anybody want to suggest how I could go about finding the slope of the line? Nobody has any ideas? Okay. Then I guess I'm gonna have to do it myself. Remember what we said, whenever we want to find the slope of a line and we're given the equation of the line, this is the equation. We want to find the slope, all we have to do is figure out what the y is by itself. We have to take the equation, which is the 9x minus 6y equals 12, and get the y alone. Now, remember, when we're doing this, we look upon the y as our variable, and any other letters, we treat them as if they were regular numbers. Whatever I would do to regular numbers, that's what I do to this. So I want to get the y alone. So the first thing I want to do is get rid of this negative 9x. So I will add 9x to both sides of this equation. So this will cancel out, and I'll be left with negative 6y equals 9x plus 12. Remember, I always tell you to put the x term first and the number term second. The next thing we do is we divide by the coefficient of the y. What is the number in front of the y? In this case, it's negative 6. So I'm going to go ahead and divide every single term by negative 6. So that I end up with y equals, well, 9 divided by negative 6. So I can reduce that. I can divide the top and the bottom by negative 3. That'll give me 2 on the bottom and negative 3 on the top, negative 3 over 2x. And 12 divided by -6 gives me -2. If I can't, there would be nothing wrong leaving this 9 over -6, and if you said the slope is 9 over -6, that would be completely correct. But if you were told to give it in simplest form, you would have had to reduce it to -3 over 2. It's better not to leave the negative in the denominator. It's better to put it either in front of the fraction or in the numerator. Remember, when you have a negative in a fraction, it can either go on top or on bottom or in front, and it all means the same thing. Okay, so now that we know that this is the slope of the line, let's see what that information tells us. What does the slope tell us? Again, the slope tells us rise over run. It tells us as you go from one point on the line to another, how to do that. A slope of -3 over 2 means you're going that from one point, you're going down 3, 2 to the right. Down 3, 2 to the right. It happens to be that the y-intercept of this line, which we get for free, we weren't asked about it, but we have it, is -2. So again, it would have been easy for me to draw this line now by starting on my y-intercept, which we said is -2, because we see this right over here. And from there to go down 3, 1, 2, 3, 2 to the right. That gives me another point on the line. Or I could have done just the opposite. I could have gone up 3, 1, 2, 3, and 2 to the left. And again, if you see that, then how these points all line up. And notice the line, as you're going from left to right, is slanting down. It's going from a higher point to a lower point. Remember, we always discuss how a line goes as it goes from left to right, and a negative slope means the line is slanting downward as you go from left to right. So if we're given the equation of a line, if we put the equation in the y equals mx plus b form, if we solve for y, if we get the y by itself, then the number in front of the x is going to be the slope of the line. But what if I wasn't given the slope of the line? We weren't given the equation of the line. There is another way to find the slope of the line, and that depends on knowing 2 points on the line. Okay, so here's another type of question. Suppose I give you these 2 points. Suppose I give you the point 3, 7 and -1, -6. And I tell you, these 2 points are on a line. We obviously could draw the line because we could just plot the points on a graph paper, and then we would see the line. But suppose I don't even care if you graph the line. I want to know what is the slope of this line. And I can't solve the equation because I wasn't given the equation. But there is a formula for the slope. That formula is something that's so important, you must know this by heart. It's the slope formula goes like this: y2 minus y1 divided by x2 minus x1. Now, what these subscripts on the numbers mean are just telling you we have 2 points here. Let's call one point 1 or our first point, and the other one we'll call point 2, our second point. When I talk about x1 and y1, I'm talking about the x and y of the first point. When I talk about x2 and y2, I talk about the x and y of the second point. In other words, this would be my x1 and my y1. This will be my x2 and my y2. Notice I always pair up the x1 with the y1. I have to be very careful about doing this in the right order. And so again, these subscripts are just to differentiate between the x of the first point and the x of the second point, or the y of the first point and the y of the second point. So this says to do y2 minus y1. So my y2 is -6 and my y1 is 7. So we do -6 minus 7. And my x2 is -1 minus 3. And all I have to do is simplify these numbers. So on the top, I have a -6 and a -7, which gives me -13. And on the bottom, I have a -1 minus 3, which gives me -4. And after I've done that, I try to reduce it because we do like to have our slope in simplest form. And since this is a negative over a negative, it becomes a positive, but nothing else reduces. Remember, you want your slope to be a fraction. Don't change it to a decimal. The slope of this line is 13/4, which tells you that as you go from one point on the line to another point on the line, you're rising 13 and you're running 4. You go up 13, 4 to the right, or vice versa. You can go down 13, but then you have to go 4 to the left because it could be negative over a negative. Okay, I'm going to give you one to try, and I hope to see some answers. Let's see if you can find the slope of this line. Find the slope between 5, -6 and 2, -4. Find the slope. Has anybody done this?
Is it 10/3?
Is it 10/3? Well, let's see. Who answered me, by the way?
Who asked? It was Tiffany that
Okay, you want to tell me how you did it?
asked. Okay. I did -4.
Okay, so you're calling this your X1 and your Y1, correct?
Yes.
And this is your X2 and your Y2. So you did -4,
-4, take away -6,
minus,
-6.
is it just -6?
-6.
Minus -6, right? There are gonna be two negatives here because it's Y2, -4, minus the Y1, and the Y1 itself is negative. Notice I put the -6 in parentheses because I don't, when you have two negatives, you don't want them to slide into one another. So therefore, you're gonna get -6. On the bottom, what did you get?
The bottom one, I got 2 minus -5. No, 5. 2 minus 5.
Okay, so all I did was take this equation and replace these numbers, okay. What do you know about a negative and a negative?
It turns into a positive.
Right, that's where you have to be very careful. Okay, so you actually get -4 plus 6. How much does that give you?
So I did it wrong.
2.
2,
Yeah, I did it.
+2, good. And on the bottom, what are you getting?
-3.
-3. So my slope comes out to be 2/-3. As I said, we usually don't leave the negative in the bottom. We generally just put it on top. It's -2/3. Be very careful with your signs of your numbers. Again, if you have a calculator, you could always stick it into your calculator. And if you put in your calculator -4, be careful to use a negative. There's a negative button and there's a subtraction button. So this is a -4 minus, which means subtract, -6. You don't have to do any of the work. It'll do it for you. It'll automatically give you the 2. So I saw a few people did get 2/3, remembering that this is a negative slope and therefore it's a line that is slanting down. As you're going from left to right, you'll be coming down. Again, if you wrote 2/-3, as some people did, that's perfectly all right. Probably if it was a multiple choice problem, they would put the negative in front rather than in the bottom. It just means the same thing. So now we see there are two ways. Yeah, you have a question. How did the example on top become 13/4? Okay, let me go back to this one. In the first one, I had the 0.37 and -1 and -6. So I did Y2, which was -6, minus Y1, which is 7. Notice there are not two negatives here. The only time you get two negatives is when you're subtracting a negative number. So this was a -6 minus 7, which would give you -13. In the bottom, you get X2 minus X1, which is -1 minus 3. And the -1 and -3 and -3 together give you -4. So you ended up with a -13 over a -4. And when you have a negative over a negative, that becomes a positive. Does that answer your question? Okay. Great. Glad it here is. Stop me if you have a a problem because I assume when I don't get questions that that I can go on to the next topic, and I'm not going on unless I feel you're ready for it. Okay, so here we are. We have found the slope, doing it two different ways. One way by using points, and one way by using the equation of the line. Okay, if you're having trouble with the signs, try and use your calculator as much as possible. If you're not sure how to use your calculator, come on early to class. I'm here usually by 9:15. Come on by 9:15 and I'll work with you with your particular calculator. It's very hard to tell you what to do on a calculator when every single person in this class has a different calculator. But one of the advantages of the calculator is that if once you get used to using it, you'll always get your signs correct. You'll get your numbers, your adding, your subtracting, all that correct. I'm not going to start teaching the rules of signs again in this class, because that really goes back to courses prior to this course. But if you need help individually, I will gladly help you. Okay, so now, and I just want to do two other examples, just as a indication of two interesting facts. Okay, so again, if we have the equation of the line, we can put it in the y equals mx plus b form and look at the number in front of the x. That'll give us our slope. If we have 2 points on the line, we can use the slope formula, and that'll give us the slope of the line. So whichever method we use depends on what information are we given. Okay, so I'm going to give you 2 more sets of points and give you a few minutes to find the slope. Okay, so this is the first one. Again, I want you to find the slope. 5, 6, and 10, 6. Okay, find the slope. And the second line that I want you to do is -2, 3, and -2, 7. Okay, so there are 2 different sets of points. I want the slope of this line. I want the slope of this line. After we find the slopes, we're going to look at those slopes, and we're going to actually look at what the lines look like. Okay, I'll give you a couple of minutes to try that. Let's look at this first one. Again, I'm going to call one of the points x1, y1. It doesn't matter which I call the x1, y1, and which I call the x2, y2. Just remember to match up the x1 with the y1. And remember, our formula for the slope is y2 minus y1 over x2 minus x1. So if I stick this into my formula, I'm going to get 6 minus 6 on the top and 10 minus 5 on the bottom. Now 6 minus 6 gives me 0, and 10 minus 5 gives me 5. So I get a fraction that has a 0 on the top and 5 on the bottom, and 0 over anything is really just 0. The slope of this line happens to be 0. I see a couple people did get that answer. Okay, let's see what this line actually looks like, because there's something about a line that has a slope of 0. Let's plot the 2 points. First, we have the 0.56. So we go 1, 2, 3, 4, 5, and then 5 to the right and 6 up. 1, 2, 3, 4, 5, 6. The second point is 10, 6. So here it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and up 6. And if I connect these 2 points, I get a line that looks like this. This is what's called a horizontal line. It's a line that goes straight across. It doesn't go up, it doesn't go down. Its slope is 0. It's as you go from one point to another, you're just going straight across. That's what we call a horizontal line. It actually, if you look at this horizontal line, here, this was a 0.56. This was a 0.106. It crosses the y-axis at 0.6 because every single point on this horizontal line has the same exact y value. That's why the equation of this line is y equals 6. So here we're looking at a special type of line called a horizontal line. Its equation is different than it doesn't have a y equals mx plus b equation. Its equation is just y equals a number. There's no x in this equation at all. And the y equals 6 is telling you that no matter what point you pick on this line, the y value is going to be 6. That's why it's all going to be straight across. It's going to be horizontal. And the slope of that line is 0. Now, this is something we're going to remember because it's easy to write the equation of a horizontal line. If I had this line, 1, 2, see, I had this line going straight across through here, and this is at -3. This would be the equation y equals -3. All you have to do is look where it crosses the y-axis. It goes straight across. All the y's are going to be -3. Again, the slope of this line is 0. Horizontal lines have a slope of 0. They have an equation y equals a number. And this is something we're going to keep in mind. Let's look at this situation. What if we want to do the slope of this line? So this one here, this would be my x1, y1, and this would be my x2, y2. And when I do the slope equation, I'll do 7 minus 3 over -2 minus -2. y2 minus y1 over x2 minus x1. And what happens here is I get 7 minus 3, which is 4. And on the bottom, again, I have that situation where I have this double negative, so that becomes a positive, and I get -2 plus 2, which is 0. And I get a number in which the denominator, the bottom of the equation, you're good, Ashley, that is perfectly correct. You get 4 over 0, and 4 over 0 is a strange number. When we're doing all sorts of arithmetic, adding, subtracting, multiplying, dividing, any two numbers, you can do anything except divide by 0. If you try to do divide by 0 on your calculator, what does it give you? Most likely, it gives you something that says error. because you're not allowed to do that. This is sometimes used, the term used for this when you divide by 0 is undefined. Or you could just say does not exist. So you could just use the term undefined, but what undefined means is that it doesn't exist. Right, 4 over 0 is not 4. 4 over 1 is 4. But 0 in the denominator is undefined. It doesn't exist. We can't use it. So if you ask me, what is the slope of this line? The slope doesn't exist. This is a line that does not have a slope. Let's look how that looks. Let's draw this picture. Okay, so first we had the point -2, 3, which meant go 2 to the left and 3 up. 1, 2, 3. That's this point. The second point was the point -2, 7. So I go 2 to the left again, and I go 1, 2, 3, 4, 5, 6, 7. So the line that we're dealing with here is a line that goes straight up and down. It's what's called a vertical line. A line that goes straight up and down is a vertical line. Here, this was my point -2, 7. And this was my point -2, 3. And the slope of a vertical line doesn't exist. It's the only type of a line that doesn't have a slope. And that makes sense. Remember, slope is telling us rise over run. Well, when I go from one point to the other, I'm going up, but I can't go left or right because there is no run. It's just going straight up. That means it does not have a slope. There's a very big difference between having a slope of 0 and having a slope that is undefined. The slope in this case is undefined. So a line that goes straight up and down doesn't have any slope, and it's called a vertical line. Also, if you look at this line, all the points on the line have their x to be -2. As a matter of fact, it has an x-intercept of -2. Never crosses the y-axis, it just crosses the x-axis. Therefore, its equation is x equals -2. So a line that's vertical, that goes straight up and down, that again does not have a standard y equals mx plus b equation. It just has an x in its equation. It's x of whatever all the points on that line are. This is x is -2. This is -2. The equation is x equals -2. And the slope of that line is undefined. There's no such slope. Okay, so those are two special lines that we can talk about. Again, we always keep in mind that horizontal lines have 0 slope, vertical lines don't have any slope, and that's something that we're always going to keep in when those are two special lines that we talk about separately. Mostly, we're going to talk about slanted lines. Lines that have a y equals mx plus b equation. And we will keep in mind that the slope gives us an idea of how the line is slanted. So I'm going to look at two lines. I'm just going to draw a picture of two lines. Let's call this line 1. And this is, let's call this one line 2. Now, if you notice, these two lines are slanted exactly the same amount. The term we have for these type of lines is parallel lines. Parallel lines are lines that no matter how far you extend them, going up, 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 or down, 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 they'll never touch. They'll never meet. They're always exactly the same amount apart. However far this is, they're always, they never get closer and closer together. They stay the same amount apart so that they never, no matter how far you would extend them, would meet. Now, just think about it. We talked about these lines are, the reason they're parallel is because they're slanted exactly the same amount. But the slant, how do we know what the slant is? That comes from the slope. So it turns out that parallel lines have the exact or equal slopes. As a matter of fact, it's a way of testing if two lines are parallel. If you're given two equations of two lines and you're asked, are these two lines parallel? What you have to do is figure out the slopes of the both lines. And if the slopes are exactly the same number, that means those two lines are parallel. Okay, so I'm going to give you an equation of two lines, and you're going to tell me if those two lines are parallel or not. So here's my first one. Y equals 3x minus 5. And my second line is the line 2y plus 6x equals 22. So this is line 1, and this is line 2. What I'd like for you to do, I'm going to give you a few minutes, figure out the slope of each of those two lines, and then tell me if those two lines are parallel or not. I'll give you a few minutes to do this. Okay, so we're looking at the equation of this first line, and it's already in the y equals mx plus b form because it's y equals. So the slope of that line, the m, is simply the number in front of the x, which is 3, or 3 over 1 if you want to write it as a fraction. That's the slope of line 1. What about the slope of line 2? So line 2 has the equation 2y plus 6x equals 22. Now, in order to find the slope of this line, I have to get it to y alone by itself, which means the first thing I have to do is get the 6x to the other side, which will give me 2y equals negative 6x plus 22. And then I have to divide everything by the 2 because I want to get the y alone. So that I end up with y equals -6 divided by 2, which is -3x, plus 22 divided by 2, which is 11. And the slope here happens to be now the number in front of the x is -3. Are these two lines parallel? Close, but not parallel. One has a positive slope, because this is going up as you go from left to right, and one of them has a negative slope. Even though they look very close, the lines are not parallel. They have to have the exact same number with the exact same sign in order to be parallel. No, these two lines are not parallel. No. Not parallel. But notice, I didn't even draw the pictures of the lines. I could just look at the numbers, the algebra, and tell if the two lines are parallel or not. Not only can I tell if two lines are parallel, I can tell if two lines are perpendicular. Let's talk about that. Two lines are what we call perpendicular. If they meet at right angles. In other words, I could have one angled line going this way, let's call that L1. And the second line would then have to go like this. It would have to meet, these are what we call right angles. They meet at square corners. Those two types of lines are called perpendicular lines. And it turns out that the slopes of perpendicular lines, the slopes are what we call opposite reciprocals. You're just going to have to take my word on this one. Where they're parallel, it makes sense that they have the same slope. But when they're perpendicular, you'd have to know a lot more math in order to accept this rule, but you're going to have to accept it. What does it mean? Let's say line 1 has a slope of 3/2. Remember, the slope is a fraction. Then in order for line 2 to be perpendicular, its slope would have to be opposite, which means the opposite sign. This is positive, so we need something that's negative. And reciprocal, flipped over. The reciprocal of a fraction is the exact same fraction, only switching the top and the bottom. The numerator becomes the denominator becomes the numerator. If you have this situation where your slopes are opposite reciprocals, then the lines will be perpendicular. Again, another example would be, let's say the slope of one line was -2. Then the perpendicular line would have to be opposite sign, so it would have to be positive, and reciprocal. Now remember, -2 really means -2/1, so therefore the perpendicular line would have to have a slope, not of negative, I'm sorry, positive 1/2. This one will always have a positive slope, one will always have a negative slope, but there'll be negative reciprocals. The only exception to this is when you have horizontal and vertical lines. Horizontal is perpendicular to vertical. So that's just something that remember, if you have a horizontal line, you want the perpendicular line, it has to be vertical. If you have a vertical line, its perpendicular line is going to be horizontal. But when you have slanted lines, the slopes have to be opposite reciprocals, flipped over opposite sides. Okay, so now I'm going to give you all right, here's what I'm going to give you. I'm going to give you 2 points. -3, 2 is 1 point on the line. And -5, 7 is another point. Here are 2 points on the line. What I'd like to do is for you to first find the slope. Second, find the slope of a parallel line. Of a line that's parallel to this line. And third, find the slope of a perpendicular line. Okay, so I want you to find the slope of the line that joins these 2 points. Then tell me if you had a line that was parallel to it, what would its slope be? And if you had a line that was perpendicular to it, what would its slope be? Okay, let's do this together. I see we had at least one person answering. Let's first find the slope. Now remember, we label one point x1, y1, and one point x2, y2. And our slope is y2 minus y1 over x2 minus x1, which gives me 7 minus 2 on the numerator, and on the bottom, -5 minus -3. Okay, so let's simplify this. 7 minus 2 gives me 5. Don't forget, when I have this double minus, a minus and a minus becomes a plus. So I have a -5 plus is 3, which is -2. So my slope is -5 over -2, or you can put the negative in front of it. That is the slope of this line, just using the slope formula. Now we want to know, what is the slope of the line that's parallel to it? Any line that's parallel to it has to have the exact same slope. So its slope also has to be -5 over 2. Again, you could write it 5 over -2 or -5 over +2. When you have a negative in a fraction, it could be in the top, the bottom, or in front. It all means the same. So the slope of a parallel line would be the same exact number, -5 over 2. Whereas the slope of a perpendicular line would have to be the opposite reciprocal. It would have to be the opposite flipped over fraction and opposite sign. That one's negative, so mine's going to be positive. The perpendicular line will be +2 over 5. So once you know that you have parallel or perpendicular lines, you would know that how to get the slope. Don't forget, you must not only flip it over, you must not only take its reciprocal, but you have to change the sign. In a pair of perpendicular lines, one of them has a negative slope, the other one has to have a positive slope. Deshauna, otherwise you did nice work. Okay. Great. Okay, we're going to stop here. Look out for homework on Delta Math. This is exactly where we're going to be taking over. Once we finish this chapter on linear equations, then we're going to have a test on both chapters 1 and 2. So we're going to, I'd say we have maybe 2 more lessons on this, and then we can talk about having a test. All right, does anybody have any questions they want to ask? If not, I'm going to end the session now. Everybody have a good day and a nice weekend. Remember, we are meeting this Tuesday, but next Wednesday and Thursday, the college is closed again. So I'll remind you on Tuesday that we will only have class one day next week, next Tuesday. Okay, have a great
Have a good
day.
day. Bye.
And yeah, see you. Bye-bye.
Have a good day, Professor.
Have
Bye-bye.
a good day, Professor.